Fluid mechanics, laminar flow, Navier-Stokes equation, viscous forces, pressure forces, gravity forces. X minus 1 over rho curl P by curl X is equal to dy by dt minus nu d square u by dx square plus d square u by dy square plus d square y by dz square. Similarly for z. Continuum mechanics. XYZ. Continued mechanics. Laminar flow is a characteristic of flow. Re is equal to inertial forces over viscous forces. Stress implies strain. dF by dA. Isotropic. Open channel flow. Viscous flow or laminar flow. Resistance between layers of liquid. Relationship between shear stress and pressure gradient in laminar flow. This is the graph. This is A, B, C, D. A dash, B dash, C dash, D dash. This can be delta X. This can be delta Y. Delta X. This is A dash, B dash, C dash, D dash. This is the graph. This is a cuboid. This is velocity profile. This is parabolic curve. This is parallelepiped. This is parallelepiped. Elementary. Total stress maybe is equal to Z plus curl E by curl Y into delta Y. Then Z plus curl E by curl Y into delta Y. Then laminar implies parabolic, transition implies parabolic, and turbulent implies logarithmic. Shear force means multiply with the area. Then Z plus curl tau by curl Y into delta Y into curl X into curl Z minus tau into curl X into curl Z is equal to curl tau by curl Y into delta X into delta Z. Here Z curl X into curl Z cancel with Z into curl X into curl Z. Then pressure force P into delta Y into delta Z minus P plus curl P by curl X into delta X into delta Y into delta Z is equal to minus curl P by curl X into delta X into delta Y into delta Z. Then curl tau by curl Y into delta Y into delta X into delta Y is equal to curl P by curl X into delta X into delta Y into delta Z. Delta X, delta Y, delta Z cancel. Then implies curl P by curl X is equal to curl tau by curl Y. Then tau is equal to mu into du by dy. Therefore dv by dx is equal to u d square u by dy square. Fluid mechanics main class. See the fluid flow with layer by layer. Derivation of Euler equation along streamline. Imaginary line if drawn tangent then find velocity. Streamline implies imaginary line if drawn tangent then find velocity. Then P into dA. This is P plus dP into dA. This is dFs. This is AS. This is theta. Normal forces due to pressure. P into dA minus P plus dP into dA is equal to minus dP into dA. Tangential force due to viscosity. dFs is equal to tau into dP into ds. How? Body force W is equal to rho g into dA into ds. Component W sin theta is equal to rho g into dA into ds into sin theta. Then sin theta is equal to dy by ds. This is equal to rho g. This component W sin theta is equal to rho g into dA into dy. Resultant force is equal to mass into acceleration. Then minus dP into dA into minus dP into dA minus dP into ds minus rho g into dA into dy is equal to rho into dA into ds into as. where rho a dA into ds is density, as is the acceleration, du is equal to curl u by curl s into ds plus curl u by curl t into dt. Then du by dt is equal to curl u by curl s into ds by dt plus curl u by curl t. Dash 1. Then dx theta dy w du. Steady flow implies du by dt is equal to dt is equal to 0, which is acceleration s. Then acceleration s, no, maybe this is acceleration s. Then as is equal to u into dy by ds from 1 and 2. From this 1 as and as 1 and 2, u into du by ds is equal to u into curl u by curl s plus curl u by curl t. Divide the equation rho into dA into ds mass. The final equation is u into du by ds plus 1 by rho into dp by ds plus g into dy by ds is equal to minus tau over rho into dv by dA, where u into du by ds is kinetic acceleration, 1 by rho into dv by ds is force per unit mass, g into dy by ds is for force per unit mass, then minus tau by rho into dv by dA is force per unit. It can also be force per unit mass. Hey, again listen. U into du by ds is a connective acceleration. 1 by rho into dv by ds is a force per unit mass due to pressure force. G into dv by ds is force per unit mass due to gravity force. Then minus tau over rho into dv by dA is force per unit mass due to shear force. Fluid mechanics. Shear stress. Stress is directly proportional to strain or rate of deformation. Tau is equal to mu into du by dy. U is equal to 1 by 2 mu into dv by dx into y square minus by. Tau is equal to minus dv by dx into b by 2 minus y. This is the diagram. A, B dash, C, D. This is B. This is Y. This is tau maximum. This is tau maximum. This is B by 2. This is L. This is x1. Then this can be x2. At y is equal to 0, tau is equal to minus dv by ds into b by 2 minus y. B by 2 minus 0. Tau is equal to minus b by 2 into dv by ds. Y is equal to b by 2, tau is equal to 0, y is equal to b, tau is equal to b by 2 into dv by dx, tau is equal to minus dv by dx, then tau is equal to minus dv by dx plus minus b by 2. Then velocity average is equal to 1 by 12 mu minus dv by dx into b square. Then pressure drop in terms of average velocity. Do not have any effect of inlet and outlet. Inlet and outlet. Velocity average is equal to 1 by 12 mu into minus dv by dx into b square. Then minus dv by dx is equal to 1 by 12 mu v average. Then minus integration dp is equal to integration 12 mu v average b square into dx minus p2 minus p1 is equal to 12 mu v average by b square into x2 minus x1. Then P1 minus P2 is equal to 12 mu v average into L by B square. Pressure head is equal to P by rho G in Bernoulli's equation. Then P1 minus P2 by rho G is equal to 12 mu v average into L over rho G B square. Then P1 minus P2 by W is equal to 12 mu v average into L by W B square. Then Y is equal to 0, U is equal to 0. This is Y, this is A, B dash, C, D. This is B, this is U is equal to V, then B. Laminar flow between plates where one plate is fixed and another plate is moving. This can be the flow. Then Y is equal to B, U is equal to V. Assumptions be same to simplify the problem. Relationship between shear and pressure gradient. dV by ds is equal to mu into d square U by dy square. Implies U is equal to 1 by mu dV by ds into y square by 2 plus c1y plus c2, which implies, not implies, then dp into ty square into dx into mu integration is equal to d square u integration, which implies 1 by mu dv by dx into y into dy is equal to u into du, then which implies 1 by mu into dv by ds, then integration dy is equal to y, implies 1 by mu dp by ds y into dy is equal to u into du, implies 1 by mu dv by dx, then d square u by dy square is equal to 1 by mu dv by dx, which implies du by dy is equal to 1 by mu dv by dx into y plus constant 1. Then 1 by y into du by dy is equal to 1 by mu into dv by dx integration. Then integration du by dy is equal to 1 by integration 1 by mu into dv by dx y plus constant 1 into dy, u is equal to 1 by mu into dv by dx y square by 2 plus c1 y plus constant 2. Then u is equal to 1 by 2 mu into minus dv by ds into by minus y square plus vy into b. Earlier given u is equal to 1 by 2 mu into minus dv by ds into by square minus y. This is by putting boundary conditions. Y is equal to 1 by 2 mu minus dv by ds by minus y square plus vu into b. Then fluid mechanics. Shear stress distribution, one plate moving and other plate fixed. Maximum shear stress at stationary plate, then moving plate. Then mu v into b minus dv by dx. This is mu is equal to v. This is b by 2. This is b by 2. This is phi is equal to 0. Mu v by v. This is fixed. Then mu v by b plus minus dp by dx into b by 2. In case of fixed plate, it was equal. Laminar flow in circular pipe. Huygens-Poiseuille law. Consider cylindrical fluid element having radius r, length is equal to dx. This is A, B, C, D. These are the lines. Then this is P, this is R, this is tau in right side direction. Here is some cylindrical like structure. Here it is P plus curl P by curl X. Here it is dx. Here it is dy. Here is P. Here is the some diagram. Here it is the lines. Here it is minus curl P by curl X into R by 2. Then equilibrium condition of summation of forces P into pi r square minus P plus curl P by curl X into dx into pi r square minus tau into 2 mu r into dx is equal to 0 dash 1. Pressure is equal to force upon area is equal to stress at periphery. Shear stress implies minus curl P by curl X into dx into pi r square minus 2 pi r into dx into tau is equal to 0. Then tau is equal to minus curl P by curl X into r by 2. Newton's law of viscosity. Tau is equal to mu into du by dy implies tau is equal to minus mu into curl u by curl r. Since r minus y is equal to small r, implies y is equal to capital R minus small r, then implies dy is equal to minus dr by differentiating. Velocity distribution. Maximum at ends which r is equal to capital R. If small r is equal to capital R and if small r is equal to 0, then tau is equal to minus curl P by curl X into r by 2. Velocity distribution in pipe minus mu into curl u by curl r is equal to minus curl P by curl X into r by 2. Implies curl u by curl r is equal to r by 2 mu into curl P by curl X. P as pressure can't be a function of r. Pressure is not changing at radius direction. Implies integration curl u is equal to integration r by 2 mu into curl P by curl X into dr. Then u is equal to 1 by mu into curl P by curl X into r square by 4 plus constant. When small r is equal to capital R, u is equal to 0. Then 0 is equal to 1 by mu curl P by curl X into r square by 4 plus c. Then implies c is equal to minus 1 by mu curl P by curl X into r square by 4. Therefore u is equal to 1 by mu curl P by curl X into small r square by 4 minus 1 by mu into curl p by curl x into capital R square by 4. Then therefore u is equal to minus curl p by curl x into capital R square minus small r square by 4 mu, which is the equation of a velocity, which is parabolic equation. Then this is paraboloid. Where would be the maximum velocity? Maximum velocity when small r is equal to 0, v maximum is equal to 1 by 4 mu into minus curl p by curl x into capital R square. Fluid mechanics normal class. Velocity profile in flow between parallel plates and flow in circular pipes in turbulent logarithmic profile is there. In transition flow parabolic profile will be there. Position of maximum velocity, u is equal to 1 by 4 mu into minus d curl p by curl x into capital R square minus small r square. Then this is the some concave like structure. This is implies maybe convex like structure. This is then implies du by dx is equal to 0. Then du by dr is equal to d by dr into 1 by 4 mu minus curl p by curl x into capital R square minus small r square. Then du by dr implies du by dr is equal to plus 1 by 4 pi curl p by curl x into 2r. Then 2 cut with 4 gives 2. Du by dr implies du by dr is equal to curl p by curl x into r by 2, which is equal to 0, which implies small r is equal to 0. Therefore velocity maximum is equal to 1 by 4 mu into minus curl p by curl x into capital R square. For estimating volume of flow rate, dq is equal to u into dA is equal to u into 2 pi r into dr, which implies integration 0 to r dq is equal to integration 0 to u into 2 pi r into dr is equal to integration 0 to r 2 pi r into dr into 1 by 4 pi into minus curl p by curl x into capital R square minus small r square. Then q is equal to 2 pi over 4 mu into minus curl p by curl x into capital R square into small r square by 2 from 0 to capital R 0. 2 cut with 4 gives 2 minus 2 pi by 4 mu minus curl p by curl x, then small r 4 by 4, then capital R 0 is equal to pi by 2 mu minus curl p by curl x into capital R square by 2 minus 2 pi by 4 mu minus curl p by curl x into r cube by 3 pi is equal to pi by 2 mu minus curl p by curl x into capital R raised to power 4 by 2 minus 2 pi by 4 mu is equal to into minus curl p by curl x into capital R raised to power 4 by 4 implies capital Q is equal to pi by 8 mu into minus curl p by curl x into r raised to power 4. Average velocity is equal to velocity average is equal to q by a. Then implies velocity average is equal to q by pi r square. Implies velocity average is equal to 1 by 8 mu minus curl p by curl x into capital R square. Rating velocity maximum to velocity average, and velocity average is equal to half of velocity maximum. Question of competitive existing question of competitive dash 4. Then pressure drop in terms of average velocity. Pressure drop in terms of average velocity. Then fluid mechanics. Laminar flow around a sphere. Stokes law. Buoyant force. This is Fd. This is W. This is Fd. This is buoyant force. This is W. Terminal velocity. Diameter sphere d. Constant velocity v. Fluid viscosity mu. Then this can be the level. Here is the up to the level. Buoyant force plus drag force is equal to gravitational force. In equilibrium condition, buoyant force plus drag force is equal to gravitational force. Buoyant force plus drag force is equal to gravitational force. Then implies pi by 6 d cube into w plus Fd is equal to pi by 6 into d cube into ws. Implies Fd is equal to pi by 6 d cube into ws minus w, which is submerged weight of sphere. Stokes has given equation for Fd is equal to 3 pi mu Vd from 1 and 2. 3 pi mu Vd is equal to pi by 6 d cube ws minus w. Submerged, which is submerged weight of sphere Fd. What is w and ws? This is V is equal to dq d V is equal to d square by 18 mu into Ws minus W is the terminal velocity. Increasing Re implies decreasing mu, implies velocity increases. In sedimentation, velocity increases, which in the flow is required. In sedimentation tank, maximum mixing alum, then increasing diameter of suspended particles. Dust particles imply decreases mu. Sedimentation tank can decrease mu, maybe settling down. High velocity will have fluctuation, and so particles may not settle down. So less or least velocity is required as minimum velocity as it settles down. So laminar flow is correct or recommended for sedimentation tank. Increasing Re implies decreasing mu, implies velocity increases. Flow is required. In sedimentation tank, mixing alum, then increasing diameter of suspended particle. Dust particles implies decrease in mu. Sedimentation tank can decrease mu, maybe settling down. High velocity will have fluctuation, and so particles may not settle down. So less or least velocity is required as minimum velocity as it settles down. So laminar flow is correct or recommended for sedimentation tank. The drag force Fd for any other shape of the body, Fd is equal to Cd into A into rho v square by 2. Cd is equal to coefficient of drag. A is equal to projected area perpendicular to the direction of flow. Fd is equal to Cd into 1 by 2 rho v square into A. For sphere case, Fd is equal to 3 pi mu Vd dash 2. From 1 and 2, 3 pi mu Vd is equal to Cd into 1 by 2 rho v square into A. 3 pi then implies 3 pi mu Vd is equal to Cd into 1 by 2 rho v square into pi by 4 d square. Then Cd is equal to 24 by mu rho Vd. Then implies Cd is equal to 24 by Re, which implies 4 infinite dimensions. Then coefficient of drag in case of sphere, finite dimension, then Cd is equal to 24 by Re into 1 plus 2.1 d capital D by capital D1 whole. These equation holds or work well when at low Re and Re less than 0.2. What is D1? If a merged body example are submarines, towers, but the main part was Stokes' law. Laminar flow through porous media. We can find in Modi and Seth book. Fluid mechanics. Frank M. White, laminar flow through porous medium. This is the level. This can be the a level of the box or some object. This can be the level. This can be the level. Consider circular pipe of length L. C by S area is equal to A. Grain diameter is equal to small d. Let Q is equal to discharge. W is the specific weight. So we consider whole area. This apparent velocity or superficial velocity, mean velocity. V is equal to Q by A. Then efficiency effective ratio of the area. Therefore efficiency is equal to AP by A is equal to area of pores over total area. Actual mean velocity of flow of liquid through pores is equal to Q by AP is equal to Q by efficiency area is equal to V by efficiency. Actual mean velocity greater than apparent mean velocity. Therefore head loss would be there. We know that loss of a head for laminar flow through a pipe HF is equal to 32 mu VL over WD square is equal to 32 mu V average into L by WD square. For plates, HF is equal to 32 mu V average into L by WB square with 32 or other number. HF is equal to K mu V average into L by WD square. Then laminar flow through porous medium. Then P1W, this is D, this is P2 by W, this is HF, this is Z2, this is length L. In porous media, average size of porous is equal to grain diameter of soil is equal to ds. V is equal to small v by efficiency. HF is equal to K mu VF by L over W ds square. V is equal to W ds square over K mu efficiency, which is K, into HF by L, which is I. Then V is equal to K into I. I is a hydraulic gradient. K is the coefficient of permeability. Then Darcy's law, 1 implies V is directly proportional to I. If we will increase the velocity sliding and these particles were not mixing, implies laminar flow. Rho Vd by mu, inertia force may accelerate the force. Viscous force is unstable forces, layers parallel than present in wavy nature. This can be the straight line, this can be the layers, this can be the layers, this can be the layer, this can be the layer. Turbulent flow if viscous force is unstable and inertial force is stable. This can be the graph. This is earthquake is dynamic. Earthquake is dynamic force. Note here, earthquake, note here, earthquake is dynamic force. Seismograph, log graph. Then this is the graph. This is the boundary layer. At turbulent flow, near the boundaries are adjacent, not mixed with boundary, behaving like laminar flow, called laminar sublayer. At turbulent flow, near the boundaries are adjacent, not mixed with the boundaries, behaving like laminar flow, called laminar sublayer, and the linear graph be there of velocity profile. This is the linear graph. Turbulent flow, this is instantaneous velocity, this is velocity u, this is the graph, this is u dash, this is u, this is u dash, o, this is s, this is time, this is 30 seconds. Then Reynolds decomposition of instantaneous velocity, u is equal to u bar plus minus u dash, semicolon, u minus u bar is equal to u dash. This is very important. U minus u bar is equal to u dash is very important. Positive or negative fluctuating velocity. Water hammer effect. Streamwise velocity V and W. U minus u bar is equal to u dash. V minus v dash is equal to w minus w. Similarly, w minus w bar. Then u bar is equal to u bar. Then u bar is equal to 1 by t. Summation from I is equal to j to n ui. Turbulent intensity will tell how much turbulence in flow. Then fluid mechanics. This is turbulent flow. This is instantaneous velocity. This is u. This is time t. This is u bar. This is u dash. Then u bar is equal to 1 by t. Summation from I is equal to 1 to n ui. U dash square bar is equal to 1 by t. Summation from I is equal to 1 to n. Then ui dash square. V dash square bar. W dash square bar. Reynolds decomposition by instantaneous velocity. U is equal to u bar plus u dash. U dash is equal to u minus u bar. P dash is equal to p minus p bar. T dash is equal to t minus t bar. And rho dash is equal to rho minus rho bar. Degree of turbulence is equal to under root of 1 by 3 u dash bar square plus v dash square bar plus w dash square bar. Intensity of turbulence is equal to 1 by v into under root 1 by 3 u dash square bar plus v dash square bar plus w dash square bar. Isotropic and homogeneous. U dash square bar is equal to v dash square bar plus is equal to w dash square bar. Kinetic energy is equal to half mv square. Kinetic energy turbulence is equal to half mv square per unit. Kinetic energy turbulence per unit mass is equal to half v square is equal to half ui dash square plus v dash square plus w dash square. Hot wire, anemometer, diffusion and flow of a visualistic technique. Measurement of turbulence quantity using ADV, which is acoustic Doppler velocity meter. Acoustic Doppler velocity meter. Measurement of turbulence quantities using ADV, acoustic Doppler velocity meter. No stress is equal to minus rho into u dash whole bar. Flow loss in pipes. Case first, major forces, then second, minor cases. This is first, frictional force is directly proportional to VH1, frictional force is directly proportional to L, frictional force is directly proportional to P. For commercial pipes, N is equal to 2. This is P1, this is alpha, this is P2. This is length L, this is alpha, this is alpha. This is P1 minus P2 into A by W. Frictional force is equal to F dash into LPV square. F dash is the non-dimensional factor. P1 minus P2 by W is equal to FLPV square by AW is equal to HF, which is Huygens-Poiseuille equation. This is dash 1. Friction force is directly proportional to V ratio of friction force is directly proportional to L. Friction force is directly proportional to P. For commercial price, N is equal to P1 P2 alpha alpha L. P1 minus P2 into A by W dash. Friction force is equal to F dash L PV square. F dash is a non-dimensional factor. P1 minus P2 by W is equal to F small f L PV square over AW is equal to HF, which is Huygens-Poiseuille equation with dash 1. Roughness more implies efficiency more. Then A by P is equal to hydraulic mean depth, which is Ym. From one end to P1 minus P2 by W is equal to FPV square over Ym into W. HF is equal to 2F dash G by W into L by Ym into V square by 2G, which is unit of HF. HF is equal to FL V square over 2G Ym. Then Darcy-Weisbach equation. Then HF is equal to 4F LV square over 2GD. Then F is the Darcy-Weisbach constant. Note here, HF is equal to FLV square over 2G Ym. Then HF is equal to 4F LV square by 2GD, which is there, or F is a Darcy-Weisbach constant.